So today we'll discuss about motion in one dimension. This is the second chapter of class 9. Okay, motion in one dimension. So before starting the thing, motion in one dimension, we'll discuss little about the physical quantities and the types of physical quantities. Then we'll go for this chapter. So first, if I'm talking about what is a physical quantity, we know that anything which can be measured, that is known as physical quantity. Anything around ourselves that can be measured directly on or indirectly, that can be known as physical quantity. There are two types of physical quantities are there. One is known as scalar quantity and another is known as vector quantity. This is new to you, but physical quantity you have already learned in class 7, 8, everywhere. So what is a scalar quantity and what is a vector quantity? What is scalar quantity? The quantity which is known as scalar, that is having only magnitude. The quantity which is having only magnitude, no direction is involved there, that quantity is known as a scalar quantity. What is the example of it? Assume if I want to measure the length of a stick. Okay, so if you measure it, assume it is 10 feet. Okay, or it may be 10 centimeter, or it may be 20 kilometer a distance. Everywhere, see, we want to express it by a magnitude and a unit. Okay, so this is the magnitude and this is the unit. Here you see, we don't need to say what is the direction of this stick or road, okay, or that distance. Here we just want to measure simply we want to measure the magnitude of it. Similarly, if I want to find the mass of a body, assume it is 50 kg, it may be 60 kg, that is also same. So we can say that length, we can say that mass. This type of physical quantities are there where no direction is needed, magnitude is enough to express it. These quantities are known as scalar quantity. Now I am coming to the vector quantity. What is a vector quantity? A vector quantities are such which needs a magnitude as well as a direction to express it. Both the things are needed. We need magnitude as well as the direction. Okay, example, assume if I am telling I am applying a force on a body of 5 Newton. I am applying a force on a body, it is 5 Newton. Then your question will come, sir, in which direction you have applied the force? Either in this side or in this side or here or here. You have to mention it. If you have not mentioned what is the direction of force, then your expression of that physical quantity is not clear. So we can say that force is a such kind of physical quantity where both magnitude as well as direction is needed. Okay, not only force, we can say that velocity, we can say that acceleration. These are the quantities are there which needs a direction to express it. Okay, so here we have learned there are two kinds of physical quantity. One is scalar, another one is vector. Scalar, which needs only magnitude to express the quantity. Vector, where we need both magnitude and direction to express it. Now we are coming nearer to our chapter where we have to discuss about rest and motion of a body. Assume you are just sitting inside a room and you thought that you are in a rest position. Why? Because with respect to the furniture inside your room, you are static, you are not changing your position. Okay, and that's why you are rest. And assume after some time you are going out from the room, and there with respect to that furniture you are moving, and then we are telling we, the body means you, are in motion. So if I just want to define rest and motion, what should be the expression of it? The expression should be very simple, that with respect to some reference, if you are not changing your place, then you are telling that you are in rest position. Means if a body is not changing its place with respect to some object or with respect to some reference, that is called rest. And when with respect to some another body or with respect to some another reference, if you are changing your position, this is called motion. Okay, that means you are standing nearer to the road and the bus is just passing you. That means with respect to you, the bus is moving. But assume a passenger who is sitting inside the bus, and with respect to his co-passenger, he is not moving. Assume you are coming from school by bus and then you are sitting beside your friend. Both of you are static with respect to each other. But with respect to your parents, whenever you are coming or going by bus, you are in motion. So when I change the reference, the idea of rest and motion is changed. Okay, assume what are the things inside the earth, not inside, on the surface of the earth. We are telling that it is static. Assume a tree, assume the buildings, we are thinking these are static. But if I am talking about the whole universe, we know no other object is static, all the things are moving. We know the earth is moving around the sun. That means the object over the earth, they are also moving with a velocity. That means no body, we cannot say it is ultimately in rest, that is in eternal rest, and no body we cannot say it is in eternal motion, because with respect to a body we represent the motion. That body is also not static fixed. Okay, next we will go for that the references with respect to which we are telling a body is in rest or in motion. These are known as frame of reference. What is frame of reference? Frame of references are the objects with respect to which we represent the rest or motion of a body. So that objects are called, or that combination of the objects are called frame of reference. Okay, now we'll go for motion in one dimension. Okay, what is motion in one dimension? That is the heading of the chapter that we have to discuss now. Motion in one dimension. Motion in one dimension means if a body, assume this body, is moving in a straight path. Okay, if a body, it is starting from A and coming to the point B in a straight path, in a simple straight path. So to represent the motion, okay, we don't need another axis. I'm just telling you some graphical things here. Assume when we represent a graph, we need a x-axis, we need a y-axis. If it is a three-dimensional one, we need a z-axis also. But if a body is only moving along x-axis, so along y, along z, what will be the change of position? We know it is 0. The position is changed only in x direction. So here y and z is not needed to represent the motion of the body. And that's why we just take only one axis to represent the motion. And that's why it is known as one-dimensional motion. That means if a body moves in a straight line, okay, that type of motion is known as one-dimensional motion. Now, to represent a one-dimensional or a three-dimensional motion, we need some physical quantities to represent or to express this kind of motion. So here we want to discuss one by one what physical quantities we have to discuss here. First, the quantity we are going to discuss, that is distance. Okay, we are using the term many a times, that is distance. Okay, what do you mean by distance? It tells us distance is basically the total path length covered by a body. Total path length covered by a body is known as a distance. Assume this is a point A, this is a point B. If the person is starting from A and going to B by this way, okay, so this total path length, just like S, that is the total distance. You can go on by this way also, you can go on by this way also. So everywhere whenever the person will go, the value of distance will be changed. That means, assume you are if I'm talking about the simple thing, assume you are at your home, you want to go, assume city center, the mall, okay, Ambuja. So you can go by various paths. You can go through the Makhan Baur Bazar, you can go by the short route through HRL, you can go by any way. So there the covered distance will be changed. Okay, whenever you are taking different path, your distance will be changed, and that is called the total path length. Okay, what should be its SI unit? If I'm talking about the SI unit of distance, the SI unit of distance is meter. Why? Because it is basically a length. Distance is nothing but a length, so we know SI unit of length is meter, so SI unit of distance is also meter. And now what are the characteristics of it? Number one characteristics, it never be zero. If you are covering a distance, okay, your total path length cannot be zero. Okay, as you have covered a distance, that means there should have a definite value. If you change your position, there should have a definite and a positive value. Okay, next one, number two, it never be negative. Distance is a quantity which never be negative. You cannot able to take distance as a negative, because here you want to find out the total path length. So total path length means you have to add something. Here is not a chance to minus anything. And now the third one, it's a very important one. It is a scalar quantity. Why? Whenever we are representing the distance, assume I am telling the distance from here to Kolkata is almost around 200 kilometer. So 200 kilometer, whenever I have told, we don't need to say the direction. We just tell the total path length of here to Kolkata. So it is a scalar quantity. Here no need to express the direction, only magnitude is enough to represent it. Now we'll go another quantity. Okay, let's see. So it is distance. I think it is clear to you. Now we'll go for displacement. Okay, next physical quantity is displacement. What is the definition of displacement? It tells us that displacement is shortest path length of 2 points or between 2 points in a particular direction. What is it? Shortest path length between two points in a particular direction. Assume we are talking about the point A and B. You are starting from here and going to B by this path, and if I find out the total path length, that will give the distance between them. What is the shortest path length? The shortest path length should always be a straight line. Okay, because the shortest path length between two points, that should be a straight line. It cannot be a curve. Okay, so we can say that the shortest path length, the magnitude of shortest path length is the distance, the shortest distance between two points A and B in a particular direction. If we start from A and going to B, then my direction of displacement is A to B. Okay, simply if anyone is asked to tell the direction of Kolkata, so we can say that along this direction, along north side, it means from my home we can say that along north side, if you are linearly go by 80 kilometer, then you can able to reach Kolkata. That means here direction is important to represent it. And now if anybody asks that if anyone just go by A to B in a straight line, then the covered distance and displacement will be same. If a body just move by a straight line, then distance and displacement will be same. Clear? So if distance and displacement will be same, then we can say the body is moved in a straight path. And straight path means it is one dimensional motion. That is motion in one dimension. So when we represent anything in motion in one dimension, then we can use anything, that is distance and displacement, any of the term, that is same, because in straight line motion distance and displacement are same. Now we'll come to the next part. What should be its SI unit? See, displacement is also a length. So here we just say that displacement also represent by meter. It is also a measuring of length. What are the characteristics of displacement? What is it? So first one, it can be zero, means the magnitude of the displacement, okay, the magnitude be zero. Okay, magnitude can be zero. How? Assume you are starting from A to B and then you return to A again. You are going by this path and you have returned by this path. Then now what will be your position? Your position will be same. You are starting from A and ended at A also. That means your basic displacement or shortest path length, that will be zero. So if you are starting from A and ended also at A, then your magnitude can be zero for displacement. Next point, it can be negative also. How? Assume if I am drawn a number line 0, 1, 2, 3, 4, 5, and here it is -1, -2, -3. Assume this point is O. So a boy or a man starting from O point and going up to here, okay, and he is returned to this point. Okay, so this point you are taking, it is A and here it is B. So he is starting from O going to A and then return to B. Then what will be the distance if I measure this one in kilometer? So the person who has gone from 0 to 5 means 5 kilometer here, and from 5 he has returned here, so again 5 kilometer means 10, and in this 13. Okay, so total distance will be 13. Why? Because here we just want to measure the total path length. But if I am talking about the displacement, If I'm talking about the displacement, when the person go in right hand direction, that will be taken as positive, that is plus 5. When he return from A to O, then it is minus 5. Then he is coming to its initial position, the displacement is 0, plus 5 and minus 5. So the first point is again proved that magnitude can be 0. And then from O, he is coming to the point B. So here in this direction you see minus 1, minus 2, minus 3. So it is minus 3. So total displacement will be minus 3 kilometer. Okay, so displacement can be negative. If your direction is changed, then the displacement can be negative here. So here we can say the displacement can be negative. Number 3, it is a vector quantity. Why it is a vector quantity? Whenever we represent the displacement, we need a direction to express it. Without direction, we cannot express the displacement. So we can say that displacement is a vector quantity. And now, if anybody tells us to find the difference between distance and displacement, the two things we have learned. So first one, distance is the total path length. Displacement is the shortest path length between 2 points. Number 2, the distance cannot be 0. Displacement can be 0. Distance cannot be negative. Displacement can be negative. And distance is a scalar quantity. Displacement is a vector quantity. Okay, so these 4 difference we can write. So I am not make you write down the difference. I am giving you the homework that you have to write it down by your own, the difference between distance and displacement. Okay, the difference between distance and displacement. Okay, now we will just learn little bit about uniform and non-uniform motion by the idea of distance. We have got the idea of distance and displacement. By the idea of distance, we learn little bit about uniform and non-uniform motion. I know that you have learned earlier what is uniform motion and what is non-uniform motion, but here we will see it little bit. Okay, what is uniform motion? What should be what by which we can able to define it? The uniform motions are those where we have seen the body covers equal distance in equal interval of time. That type of motion is known as uniform motion. If I want to give the example of it, assume a person starting from here O. After 5 seconds, he covers 10 kilometer. I'm sorry, 10 kilometer is little large. Assume 10 meter. In next 5 seconds, he covered next 10 meter. In next 5 seconds, 10 meter. Next 5 seconds, 10 meter. So every equal time interval, the person covers 10 meter. Okay, that means every interval of time he covers equal distance. So we can say in total 20 seconds he covers 40 meter, but the motion is uniform because every equal time interval he covers equal distance. And now we are coming to the non-uniform motion. What is non-uniform motion? Let's see. Non-uniform motion means, assume he is starting again from O. So first 5 seconds he covers 10 meter like the previous. Next 5 seconds he covers 5 meter. Next 5 seconds he covers 20. And next 5 seconds he covered 5 meter. Okay, so here also you see the body covers exactly 40 meter like the previous, but every equal time interval, means every 5 seconds the covered distance is not same. First it is 10, then it is 5, then it is 20, and then again it is 5. So that type of motion is known as non-uniform motion. So non-uniform motion means if a body covers unequal distances in equal interval of time, that is known as non-uniform motion. So based on distance we can differ, or we can make, there are two types of motion. One is uniform and another one is non-uniform motion. Now we'll learn some another physical quantities to represent the motion. Okay, let's see. So first physical quantity we have learned distance, then displacement. Now we are coming the another one, that is speed. So we are very much accustomed with that name of this quantity, the speed. What is speed? The speed is basically the distance covered by a body in unit time is known as speed. So speed is basically the ratio of distance or total distance by time. So if I denote speed by s, so s equals to d by t. Okay, and if I want to find out the distance from the idea of speed, so d equals to st. Okay, just simple cross multiplication. So speed is nothing but the ratio of distance and time. So that is very common if I am talking about unit. Okay, so unit of distance, that is meter, SI unit. Unit of time, it is second. So the unit of speed is meter per second. Now what are the characteristics of it? That is important here. Okay, number one characteristics tells us the speed, it never be zero. The speed of a body never be zero if the body is in motion. If the body is not in motion, then it can be zero, but if the body is in motion, then it never be zero. Why? What is the reason behind that? The reason is, okay, so we are discussing the characteristics of speed, the properties of it. So it never be zero. Why? What is the reason behind that? Because we know the distance cannot be zero, and as speed equals to distance upon time, so the speed also cannot be zero. Number 2 point, it cannot be negative. Why it cannot be negative? Because as similar logic, the distance cannot be negative, so we know the speed also of a body, it cannot be negative. And number 3, same with the distance, that is, it is a scalar quantity. Why? The reason is that by which quantity the speed is formed, distance and time, both distance and time are scalar quantity. So as distance and time is scalar quantity, so the speed, it is also a scalar quantity. Okay, so these are the characteristics of speed. Talking about speed, then we have to learn little about average speed. Average speed is what? When we want to find out the total distances upon total time, then we find the average speed. Mean, assume a body covers different distances in different interval of time. If it is asked that what will be the total speed of that body, in that case we are finding out the average speed. So average speed is basically total distance by total time. So if the body covers different distances like d1 plus d2 plus d3 plus dn with the time interval t1 plus t2 plus t3 tn, then the sum of distances with the ratio If I'm taking the ratio of sum of distances to the sum of time period, then we'll get average speed. Okay. Next, we are going to the another physical quantity, that is velocity. What is velocity? See, whenever we have just learned the name, listen the name, the speed and velocity, both the things seems to be like same, like distance and displacement. It seems to be like same, but velocity is not same with the speed. What is velocity? In speed, we have learned it is the rate of covered distance, that is distance per unit time. Velocity is nothing but displacement per unit time. So if I am talking velocity is v and displacement we are talking s and time t, so here v equals to s by t, and if I want to find out s, so s equals to v into t. Okay, so that is the definition, that is where displacement per unit time is known as velocity. So displacement is also denoted by meter, so its SI unit should be meter per second. What are the characteristics? Number one, it can be zero. Why? What is the reason behind that? Simply, as we know, the displacement can be zero. So the velocity of a body, that also can be zero because it is displacement by time. If displacement is zero, then our velocity should also be zero. Number two, it can be negative. Why? As the displacement can be negative. If the displacement is negative, then we can say the velocity of a body should also be negative. Number three, it is a vector quantity. Why? Because we know displacement, it is a vector quantity. Maybe we know that the time is a scalar quantity, but as displacement is a vector quantity, that's why the velocity of a body, that will also be a vector quantity. So by these characteristics we can able to make differentiation between between speed and velocity. So it is very much common to us, so we are not going for that. If it is coming, then you can able to write down by your own that speed is the ratio of distance and time, velocity is the ratio of displacement by time. Speed cannot be zero, velocity can be zero. Speed cannot be negative, velocity can be negative. Speed is a scalar quantity, velocity is a vector quantity. If I am talking about what is average velocity, like average speed, so if I want to find out the average velocity, that is basically total displacement upon total time. If the displacements are S1, S2, S3, Sn, then this ratio is known as average velocity. Now I am telling you one very common example that we have seen around us. Whenever we have gone by bus or bike or car, we have seen the speedometer that is shown where the driver has sit. The speedometer's pointer is changing continuously, and if it is a digital display, you see the speed is always changed or the velocity is always changed. So how can we able to measure it? See, whenever we want to find out the average velocity, for that case we need to cover the displacement, we need to cover a distance for speed at a certain time interval, and then we will get the ratio, and then we can say this is the velocity or this is the speed. But whatever the things we have seen in odometer, the instrument is just kept in front of us. In the pointer of the odometer, it is changed in a very small interval of time as the speed or velocity is changed. By the way, as we know, in a straight line path, distance and displacement is same. So in a straight path motion, velocity and speed, it is also same if the body is in one dimensional motion. Means if the body is in straight line motion or one dimensional motion, then the velocity and speed of a body will be same. Now my question is clear. To find average velocity, we have to give some time to the instrument, but the practical thing we have seen, the velocity or the speed we have measured in a very short interval of time. So what is it? So that one is known as instantaneous velocity. So by the term only, it is clear to you that by an instant you can able to find out the velocity, that is instantaneous velocity. What is instantaneous velocity? The instantaneous velocity is a ratio of a distance and a very small interval of time. A distance covered by a body or displacement covered by a body in a very small interval of time. How much small? How much small we can imagine. Okay, so instantaneous velocity, that is VI, is written as like this. This LIM means limit t tends to 0, or sometimes it is known as del t tends to 0. Why it is del t? Because we are taking the time very small, so that's why instead of t we are taking del t. Whenever we have written this del sign, that represents the time period is very small. So in a very small time interval, the displacement also very small, so del is by del t. What does it represent by this statement? By this statement, we have understood that the velocity of a body in a very short interval of time. So how can we able to find it out? So in a short interval of time, the body covers a very short displacement. So that ratio, so displacement upon the time in a very short interval, is known as instantaneous velocity. How much small time period that should be? That is been mentioned here. That is del t tends to 0. This arrow sign represent tends to. Tends to means it is very small, nearer to 0. It is not exactly 0. If del t is 0, then it will be infinity. Something by 0 equals to infinity. It is not valid. Del t tends to 0 means it is very small, close to 0, but not exactly 0. So that is instantaneous velocity, and this is average velocity. We can able to make difference between instantaneous and average velocity also. Average velocity is what? Total displacement by total time. Instantaneous velocity is what? Instantaneous velocity is covered displacement in a very short interval of time. Average velocity, that will take some time to measure, because we need to cover a distance at a certain time interval, or at certain time intervals we have to cover some distance. But instantaneous velocity will get very short time interval. Okay, so these are the two important difference of instantaneous velocity and average velocity. My suggestion is that you have to write down the difference between instantaneous and average velocity. I have not made. Now we'll discuss the types of velocity. What is that? There are two kinds of velocities are there. One is uniform velocity and another one is non-uniform velocity. Like the non-uniform motion we have discussed. Exactly the same thing is there. Why we are writing? We are writing in two part, because we want to distinguish between these two, which is important very much. What is uniform velocity? The same thing I have already told, what we have learned in uniform motion. What is told in uniform motion? Now, if a body displaces equal displacement in equal interval of time along with the direction, then that type of velocity is known as uniform velocity. I'm just telling you, very easily. Assume a body is starting from here, okay, starting from O. So when it comes from O to A, assume it is 5 meter, it will take 1 second. Next 1 second, it will go 10 meter. Next 1 second, it will go 10 meter, 15 meter. And next 1 second, it will go 20 meter. Okay, so from O to D, every 1 second the body covers 5 meter. You see, first 5 meter, then 10 meter, then 15 meter, then 20 meter. And if I'm talking about the direction of displacement, keep it in mind that when we are discussing about the velocity, we are talking about the displacement, not the distance. Okay, so here one thing we have to remember, the direction is also important. The direction is same. So we can say that if the magnitude and the direction of displacement is same in every interval of time, that type of motion is known as uniform motion and or uniform displacement, and the velocity of the body is known as uniform velocity. Okay, both, keep one thing in mind, both magnitude and direction of displacement is same in every equal interval of time. Okay. Now we'll come into non-uniform velocity. What it is told? It is told that if the magnitude, or either magnitude or displacement or both, okay, if it is changed in every equal interval of time, that one is known as non-uniform velocity. Either magnitude, okay, if I say the magnitude of displacement is changed, so same diagram, it is O. Okay, so first 1 second, assume it has gone 5 meter. Okay, and next 1 second it has gone, assume it is 20 meter. Next 1 second it has gone again 10 meter. Okay, 25. Okay, and next 1 second it has gone, assume it is 35 meter. See, in first 1 second it has gone 5 meter, next 1 second 5 plus 15, so here it is displaced by 15 meter, and here it is displaced by again 5 meter, and here it is displaced by again 10 meter. So every interval of time, maybe the displacement of the body is same. Okay, the direction of the displacement is same, but the magnitude of the displacement in every equal time interval, it is changed. So that type of velocity is non-uniform velocity. So here we have seen that magnitude is changed in every equal time interval. Okay, it may possible that the magnitude is same, but the direction of velocity or direction of displacement is changed. If we are talking about uniform circular motion, what is uniform circular motion? Now, if a body moves in a circular path with constant speed, if a body moves in a circular path, assume a body, it is here, this is the center of the path, and the body moves in a circular path with a constant speed. So if the speed is constant, we can say that the magnitude of the velocity is also constant, right? So every equal time interval it covers equal just displaces equally, so the magnitude will be same. But if I am talking about the direction, when the body is at A, the direction of velocity is along its tangent. But assume when it comes to the point B, then the direction of displacement is here. So if it occurs assuming t second, so see in t second the direction of the displacement is changed. Maybe it is already told, as it is a uniform circular motion, the magnitude is constant because the speed is constant, but the direction of velocity is changed in every certain time interval. If it comes here, then the direction of the displacement is here. If it comes here, then the direction of displacement is along this path. So the direction of displacement is along its tangent. So the velocity, whatever it is seen here, it is a non-uniform velocity as the direction is changed, but its magnitude is same. One question can come from here, that is it possible the body is moving with a constant speed but it is having an acceleration? So what is acceleration will come later, but the answer should be yes, because as here we have seen the speed is constant, but as the direction is changed, so the velocity is not constant. Every point of the motion in uniform circular path, it is changed, the velocity is changed because the direction is changed in every time interval, and that's why the velocity is changed. And later we come to know the rate of change of velocity is known as acceleration. So here the speed is constant but the velocity is changed, that's why the body is having acceleration. So this is all about the velocity. Now we'll go for acceleration, what we are talking about. What is acceleration? Let's see. Acceleration, it is also a physical quantity, which is of course a vector quantity also because it is related with the velocity. What is it? The acceleration can be found out by measuring the rate of change of velocity. What is it? We know the velocity can be changed if I change the magnitude of the displacement in every time interval, or if I change the direction of motion. In both the case the velocity can be changed. What acceleration tells us? The acceleration tells us the rate of change of velocity. That means in unit time how much velocity is changed. Okay, in unit time how much velocity is changed. So let's see an example. Let a body is moving with a velocity of u. A body is moving with a velocity of u. After time t, the velocity changes to v. Okay, so simple thing. Assume it is a body, it is moving by a velocity u, but as after time interval t, assume you are applying a force on the body, then the velocity is changed to v. Assume a football it is just moving in front of you, and when it is going in front of you, you are just kicked on it. So when you have kicked, the velocity of the body is automatically changed. That one is known as final velocity. So u is the initial velocity, v is the final one. So we can say that what will be the change in velocity? Now initially it is u, finally it is v. The change is in velocity, that is known as del v, is equals to v minus u. Achha, this change is occurred in time t. So in time t, the velocity is changed v minus u. So what is the rate of change of velocity? So if I find out the rate of change of velocity, then we have to find out the change in velocity per unit time. So it should be del v by t, that is v minus u by t, and it is known as acceleration. Acceleration is equal to v minus u by t, where v is the final velocity, u is the initial velocity, t is the time. Okay, now the question may come, sir, it is possible that initially the velocity may be more and finally the velocity is less. Assume you are going in a very clear road, then your speed will be more. Whether you are going by a bike or by a car, your speed will be more if the road is clear. Suddenly you are coming to a crossing where there is some congestion, so your speed will be decreased. So as the speed is decreased, then also a velocity is changed. So we are seeing a condition that if u is greater than v, means your initial velocity is more than your final velocity, then your acceleration, that is v minus u by t, so as v is smaller, u is greater, so v minus u by t, that value will come a negative one. Okay, the value will be negative as v is smaller than u. Okay, and this is known as retardation. This is known as retardation. What is retardation? The retardation is called or is known as negative acceleration. That means if a body's velocity is changed such a way that the final velocity is smaller than the initial velocity, that one is known as retardation, the rate of change of velocity. And here in this case, if it is positive, then it is acceleration. Okay, so two things you have learned. Acceleration and retardation both are rate of change of velocity, but when it is positive, the value is positive, it is known as acceleration. When the value is negative, that is known as retardation. Now we are going for the unit of acceleration. I think it is clear to you. Okay, now we'll go for the SI unit of acceleration. So if I'm talking about the SI unit, we'll just go by the equation we have just derived here. So SI unit, we have just learned that A equals to V minus U by T. So V minus U means change of velocity, and T, it is time. The change of velocity, what should be the unit of change in velocity? That should be the unit of velocity. So we can say, if I want to find out unit of acceleration, so it should be unit of velocity by unit of time. What is the unit of velocity? We know it is meter per second. What is the unit of time? That is second. So it will come meter per second square. That is the unit or the SI unit of acceleration. Sometimes the question may come by this way also. Why the second square? See, In denominator there is second square term is there. It is asked why there is second square term has come in acceleration. So the second square term has come due to, one has come due to the unit of velocity, one has come due to the rate of change of velocity, that is unit of time. So this is the SI unit of velocity, SI unit of acceleration, sorry. Now we are going to learn a very common thing, okay, and then the first part of this chapter will be completed, okay, and that one is the type. Okay, what are the types of acceleration? So like your velocity, like the previous one, here is also there are two type of acceleration: uniform and non-uniform acceleration. Okay, so what is uniform acceleration? It is told that in every equal time interval, if the change of velocity is same, that acceleration is known as uniform acceleration. What is it? Assume you have starting from here at O. In first 5 seconds, your velocity is 20 meter per second. In next 5 seconds, your velocity is 30 meter per second. In next 5 seconds, your velocity is 40 meter per second. So you see, every equal time interval, your velocity is increased by 10, 10, 10. So first 20 to 30, 30 to 40, 40 to, if you see another 5 seconds, it is 50. So we can say that the velocity is increased uniformly. Every 5 seconds, it is increased by 10 meter per second. That type of acceleration is known as uniform acceleration. But if it is possible, the increase or decrease, it is not occur equally in equal interval of time. Like it is starting from here, in first 5 seconds, assume it is 20. Next 5 seconds, it is 25. In next 5 seconds, so it should be meter per second. In next 5 seconds, it is 40. Okay, so you see the increase is not uniform. First 5 seconds it is increased by 5. Next 5 seconds it is increased by 15. Okay, so that type of acceleration is known as non-uniform acceleration, where the increase of velocity in a certain interval of time is not constant. And now we'll go for the last one example of acceleration, and one example whatever we are discussing, that is acceleration due to gravity. Acceleration due to gravity. So what is acceleration due to gravity and how we understand? See, most of us, mainly I'm talking about not only for boys, it is for the girls also, that sometimes we are playing with the ball. We have thrown the ball at a height and just we want to catch it. You see, whenever the ball is thrown much height, then it is difficult to catch the ball, because whenever it comes towards our hand, so if it comes from a long height, then the velocity of the ball is more, so it is difficult to catch. And if it is coming very flatly, means not coming from a long height, then it is easier to catch because the velocity of the ball is less there. So why the velocity of the ball is increased? The velocity of the ball is increased due to the acceleration of gravity. We know the force is acting by the earth towards any object at the surface of the earth, that is known as gravitational force, and when it is applied by our earth, that is known as gravity. And due to that force, okay, one acceleration is generated, and that acceleration is constant, and we denote this acceleration by the term g. Okay, and the value of g is 9.8 meter per second square. So 9.8 meter per second square, that value gives us the idea of acceleration due to gravity, and it is constant. So for this reason, for this acceleration, the velocity of the body is increased, okay, when it comes from a height. So that is all about your first chapter. From this chapter, the numerical may come by only that equation we have learned now, that is a equals to v minus u by t. Okay, so it may come by this equation also, that is s equals to v into t, where s is the displacement, v is the velocity, and t is the time. So using these two equation, we'll do some numericals of this chapter, and whatever the things we have discussed, okay, please go through the book. I think you can able to understand. Thank you.